Hello everyone, my name is Parth Kumar Singh and I am an alumni of IIT Jodhpur. Today we are going to discuss a very important question that was asked in 2021 IAT test, right? So in this question we have been given this compound PF3Cl2, right? And we have been asked to calculate, right, how many FPCl bond angles are there in most stable structure of PF3Cl2. Now this question is very simple. It seems to be simple, but what makes it difficult is that they have asked for the most stable structure for this particular compound PF3Cl2. Now it introduces a very important concept of epicophilicity. Now let me show you what epicophilicity actually means, right? So according to epicophilicity concept, if you have a geometry of trigonal bipyramidal, which PF3Cl2 will exist in here. How do I know? Because we all know this fancy formula, steric number is equals to V plus M minus C plus A by 2, where V is the valence number of electrons of the central metal atom, that is not necessarily metal, right? Phosphorus, which has 5 electrons, we know. The monovalent number of atoms around this central atom is again 5. Any positive or negative charge over this particular compound? No. So basically C is your positive charge and A is your negative charge, which is here both 0. So we will get 5. And we know that when steric number comes 5, the standard geometry or the parent geometry is trigonal bipyramidal, right? So once we are clear with the parent geometry, that is trigonal bipyramidal, we are very much sure that here the concept of epicophilicity will matter a lot, which says that the more electronegative atom would like to go on the axial position rather than going on the equatorial position. Why is that? Because it is a pretty much electronegative atom and what it wants is a constant share of bonding electron towards itself, and we know that axial bonds are pretty much longer as compared to the equatorial bonds in trigonal bipyramidal geometry. So longer bond means less percent Digi's character or less electronegativity of phosphorus towards this bond, and this is what phosphorus will want actually. So that is why out of these three, the first two phosphorus will go and occupy these two axial positions, right? Now the third phosphorus has pretty much none other choice, so it will occupy the leftover equatorial position, and then the Cl2 will come here. So this is the most stable geometry according to the concept of epicophilicity. Now what they are asking is FPCl bond angles in most stable structure of PF3Cl2 are close to. So FPCl, so this is 90, right? So you have got 190, and FPCl, the other type of angle that you are getting here is 120, right? So two types of angles are there, 90 and 120. So option A is correct. So this is how they are using very important concept of epicophilicity in this particular question, and in nearby future it is may possible that they will ask the same question on the parent geometry pentagonal bipyramidal. So you should know the same concept over that. So this was the first time when IIT asked about this, so I thought this question to be very much important and to be discussed. So in this question we have to select the chiral molecule among these four, right? So we have been given these four compounds, first, second, third and fourth, and we have to select which of these is chiral. So what is the condition for a compound to be chiral? So we have an atom, if it is chiral, it must have 4 different groups, right? So if a molecule is chiral, similarly it should have a basic condition that any one carbon or maybe multiple should have 4 different groups, right? Now look at this one. So if we clearly look at this, right, one amine group, one hydrogen group are clearly different, but are these two, the left one, the left part of the ring and the right part of the ring, different or same? So basically these are same, because you cannot differentiate these two on the basis of CIP rule. So because when you apply CIP rule on these two, basically you will end up at the same carbon from both the sides at the same time. So these are undifferentiable. So basically this is an achiral compound, not chiral. Now the second one is pretty basic. H, NH2, Me and this vinyl group, or all 4 different groups attached to this particular carbon makes this molecule chiral. So this is chiral basically, right? Now third one, look at this carbon attached to methyl, vinyl and again to the ring. But similar to this one, these two parts of the ring, the left and the right, are also undifferentiable on the basis of CIP, right? And if we look, so basically this is also not chiral. And if we look at the last one, the fourth one, at this carbon we have an hydroxyl group, a hydrogen group, right? And again this ring, but here the left and the right are completely differentiable. You can differentiate just by looking at it, because you know at the very first carbon you have 2 hydrogens, but you have here an additional methyl group which gives a priority to this one. So you can differentiate this basis on the CIP rule. So these are differentiable since this is also chiral, right? Now ultimately out of these 4 we have second and fourth as the chiral compounds. A very wonderful question that belongs to the chapter chemical kinetics. This question was asked in IAT 2021 and this question is pretty much basic, but yet it is very difficult to understand sometimes if you are weak at interpreting the graphs and the information that is given in the form of the rate constants. So basically in this question they are saying based on the relative stabilities and barriers, right? Barrier means they are considering activation energy and relative stability means that they are considering the rate constant, right? Or the free energy through the graph. Which among the following schematic energy diagram would best correspond to the reaction scheme shown below? K and K prime are similar in magnitude. Wonderful, right? So basically this K is same in magnitude, so you can consider is everything is K right here. Now you have to tell them that which of these 4 curves actually represents this particular consecutive reaction pattern, right? Now very easy, very easy. If you just know the fundamentals of reaction dynamics, you will just do this question in 2-3 minutes, not more than even 2 minutes. I'll show you this. See, X to Y, the forward reaction is 4 times the K and Y to Z is 8 times the K. What is the basic interpretation that you get from this type of consecutive reaction? It is that X to Y, if it is producing a stable product, then Y to Z is producing even more stable product, right? So what you can guess from this, that the energy of X, the free energy or the potential energy of X is highest, the potential energy of Y will be lower, and since again the rate is again the double of the first one, when it goes to Z, it means that Z is even more stable. That is why the reaction is fast, right? So Z is lowest, the potential energy, it means that your curve should be gradually decreasing for the values of X, Y, Z in the free energy. Can this be the right option, the B one? No, because Y's energy is more than X and Z, right? Or Z is fine, right? But more than X is what it is incorrect for. Now C could be a good option because the gradual decrease in the free energy is visible. But D is again the wrong option due to this Y, right? Now A is also a perfect candidate because X, Y, Z are actually having a constant decrease in the free energy, right? So these two are the valid candidates. They have actually cleared the round 1 of the your basically competition, right? Now we have to decide between these two which one is the correct, right? Now we will go backwards. So see, Z to Y, the backward reaction is 3 times the K, right? And Y to X is basically 2 times. Or even I am just about to tell you a way simpler approach than this. You need not to go even backwards. If you just look at this, the intermediate or basically transition state that forms between X and Y and transition state that forms between Y and Z has a significant energy gap. But here the difference is that the transition energy between x and y and the transition energy between y and z has a reverse gap. Means according to this graph or curve, the transition state that forms between y and z has a very high activation energy. If it is so, then why the rate or how the rate could be faster? Because you know that the rate of a chemical reaction directly relates to the activation energy, right? You all have heard that very famous equation, Arrhenius equation, right? So which relates K to the basically activation energy, and we know that less activation energy will be responsible for a faster reaction. So if the energy gap of the transition state means the activation energy when we jump from y to z is more than this, then the rate should be substantially less when we jump from y to z, rather x to y. So this graph also cancels out the perfect criteria as given in this particular consecutive reaction. So that's why our answer is option A, and this is how you do this, right? So very easy and simple. So in this question, which of the following expression represents the hydrogen atom wave function psi r, right, shown in the figure below? So basically you have been given 4 different wave functions value. Psi r means 4 different type of wave functions, one graph, 4 wave functions. All you need to do is you have to check which exact equation can justify this graph pretty much close, right? So for that, what you need to do, you need to understand a very fundamental of atomic structure, that was that whenever this curve of psi r and the radius gives a value 0 for the psi r, means it is actually the radius. This is the very important point of this question, in fact, that this gives a radius where the psi is 0. It means that it is a node, it is a radial node, and whenever we have the radial node for the value of r by a naught where the radial node exists, the psi will give 0 value, vice versa we can say like that also. So what we have to do, we have to, if any of these equations belong to this graph, then they must give 0 value for some value of r by a naught. So what we have to check, whether can these equations be put to 0 at all or not based on their mathematical functions. For example, if we look at this option B, can this 1 upon root pi give you 0? No. Can this 1 upon a naught factor can give you 0 value? No, because a naught is a constant, they have mentioned it, right? Can this e raised to the power minus r by 2 a naught give you 0? No, because exponential functions can never give the value 0, no matter whatever power it is raised to, right? So this cannot be your answer. Now option C, can this be 0? No. Can this be 0? No. Can this be 0 as a whole? No. Again, because it is an exponential factor, it cannot be 0. So basically these two equations clearly cannot give you any value for any value of r by a naught 0 wave function. Means substantially these two equations do not follow this node thing or this graph. Now the only left candidates is A and D. You have to analyze these two very carefully. Now in A, obviously this and this cannot be 0, this cannot be 0, but if this becomes 0, because this can be 0, this is just a linear function, this can be 0, and if this becomes 0, the entire wave function will become 0 for some value of r by a naught. So what we will do, we will keep this 2 minus r by a naught equals to 0, and what we will get, what we will find is basically r by a naught is equals to 2. It means that this graph says that if your curve follows this particular wave function, or this curve is basically belonging to this wave function, then at r by a naught equals to 2, this will give you a node because the wave function is 0 at this value. So if you look closely, you will find out that the value of r by a naught at which you are getting wave function 0 is very close to 2, right? However, it is just a uncalibrated form of calculating it, but we have left with no other choice. It is very close to 2 if you just try to look at this. So this is a probable answer. Now, before jumping to the answer or just clicking the MCQ, have a look on D. D also can have this factor equal to 0, right? And if we try to solve it, 3 minus 2r by a naught plus 2r square by a naught square equals to 0, right? Just consider r by a naught as x. It will simplify your equation. 3 minus 2x plus 2 by 9 x square, right, equals to 0. Take the LCM, put the 9 of the LCM to the right hand side, submerge it with 0, right, ultimately 0. So it will be 27 minus 18x plus 2x square. When you solve this quadratic equation using Sridharacharya formula that you very well studied in class 10th, that is basically minus b plus minus under root b square minus 4ac upon 2a, which corresponds to a basic general equation, that is ax square plus bx plus c equals to 0, right? So for this equation you have this. So a is basically here what? 2, b is minus 18, don't forget this negative sign, c is 27. When you solve this, you can pretty much solve this, is very simple, right? Simple. So when you solve this, you will get two values of x, means r by a naught, and both of them will be positive, right? One will be close to 2 and one will be close to somewhat greater than 5, right? Greater than 5. So basically, if it is greater than 5, then you should use this one, right? So you will get these two roots. Both of the roots have positive value, means both are a valid roots. Means this equation says that if this equation holds true for this fundamental graph, this graph will touch the psi r equals to 0 axis 2 times, because it has two roots, two values for r by a naught, for which this particular wave function gives you the entire wave function 0, right? So if this curve was, instead of what they are actually asking, if this curve was like this, then this solution might hold true, this equation might hold true, because now it is actually crossing this psi r equals to 0 2 times. So this shows that we probably get two roots, but the actual graph is not like this. Actual graph is actually giving you only one radial node, means only one probable function, one probable solution that will give you r by a naught, basically 2, and consecutively psi r equals to 0, and that is option A, not option D. So option D, C, B thus are incorrect, and the correct only option is option A. So this is how we solve these types of question. Basically, the specific reason why I have brought up this question, however, I know that this question is relatively easy for you guys, but the thing is that in the answer key that you may find on the internet, the answer was given none of the above, and the grace marks was given to all the students who have attempted this question. But the thing is that this concept is clear in the NCERT, and as per that concept, the answer should be one of these options. So that is why I have brought up this question, and today we are going to see that how does we have to solve this question. In this question, we have been given a dihalide, right? So basically, this is a adjacent dihalide, right? And we have to treat it with KOH, ETOH. Now, most of the students may get confused while seeing this mixture of KOH and ETOH, but if you look closely, it is nothing but alcoholic KOH. And we all know that what does this mixture of alcoholic KOH does? Elimination, right? So what will happen? Either of this bromine and an adjacent hydrogen will substantially leave this compound and will give a elimination product, that is this one, right? Suppose, right? Now we know that still there are two hydrogens left on this position, and this leaving group is also there. So chances of elimination are also still available. But the thing is that now if we want to do elimination, we have to use a stronger base. Alcoholic KOH will not solve the purpose here. So in the second step, what they have used, soda amide. And soda amide, now you tell me, NH2 minus, and here it produces OETO minus. Which one is a better base? You yourself know that as the electronegativity of the
atom having negative charge along the period, if we are comparing, decreases, the basicity increases. So definitely NH2 minus is a stronger base as compared to EtO minus, and thus NaNH2 serves as a stronger base here, and it tend to abstracts a proton from here and let this bromine also leave the compound, giving another molecule of HBr outside and giving you an alkyne, right? So your compound was supposed to be B, option B. But in the answer key, it was mentioned that none of these is correct. However, you can look closely into the NCRT of basically this chapter, like haloalkenes and haloarenes. You will find out basically that this reaction is given, and this concept is clearly shown that double elimination can happen if we use KOH, ETOH in the first step and NaNH2 in the second. So basically, if you like this type of question, then you can always like and show your love in the comment box. You can always tell us that what else you want to see, and this question was thus the ambiguous question in 2019, and now you know the answer too, right? Thank you.